Okay, this is a continuation of lecture number 7. In this lecture number 7, we start talking about moments and using force times distance. And so I kind of realized that the video kind of ended at the method number 2, the component method. And therefore we never finished actually the last page of the notes, and so I want to talk a little bit about the third method, which involves cross products to calculate the moment. Now the first thing I should mention is that using the cross product method is really preferable for the 3D method. Okay, so anything we do in 3D, the cross product method is probably going to be the way to go. If you're in 2D, if it's just a two-dimensional problem, you don't need the cross product method, but in fact methods 1 or 2 are probably going to be easier for you than this method number 3, but you can certainly do it. Okay, and so what I have here is an example just to kind of go over cross products. You'll see there at the bottom of the screen here I have a vector A, which consists of 2i minus 4j plus 2k, and another vector B, which is 3i minus 5j. And I want to do a cross product A cross B here. Okay, remember that a cross product, when you do a cross product, both things have to be vectors, and the result of a cross product is another vector. Okay, so A cross B, the result of that will be another vector. So how do we actually practically do it? Well, what you can do to do cross products is you want to set it up kind of like a multiplication. It is similar to a multiplication, and you can use what you may have heard of called the FOIL method. Okay, when you did multiplication in algebra, which is first, outer, inner, last, right? The FOIL method. So what we do here is we would multiply first the 2i times the 3i. Now, the thing you got to remember about cross products is I cross I is 0, j cross j is 0, and k cross k is 0. So anytime you do cross products and they're the same I, j, and k, then that cross product is 0. Okay, so the first thing we do is 2i cross 3i. Well, that goes to 0. Then I'm going to do 2i cross minus 5j. Okay, now that's I cross j. Now whenever you do a cross product and you have two letters that are different, the result is always the other letter. Okay, because there's only 3 letters, I, j, k. So if you have I cross j, then the result has to be k. You just don't know if it's positive k or negative k. Now the way I decide that is I actually use the right hand rule. Now that's difficult to show in the video, but what I would do for I cross j is I would take my right hand and I would make it even with, I would make it parallel and coincident with the I axis, with my thumb pointing in the k direction. And then what I would do is I would swing it over to the j axis. If I do I cross j, my thumb points in the positive k direction. Now I also have 2 times minus 5. So 2 times minus 5 is minus 10. So minus 10 times k would be the result. Okay? Now also you do minus 4j cross 3i. Okay? And you would do minus 4 times 3, which is minus 12. But then you do j cross I. And if you do j cross I, you're going to get negative k. So if you do the negative times the negative, you get 12k plus 12k. And then you keep going, you do minus 4j cross minus 5j, well that's going to be 0. Then you do 2k cross 3i, k cross I is going to be positive j, so that's going to be 6j right here. And then finally you've got 2k minus 5j, k cross j, okay, is going to be equal to negative I, but then it's 2 times minus 5, which is negative 10. So that creates positive 10. Okay. Now I will say also, if you want to, your calculator should be able to do cross products. You can learn how to do those on your calculator, and you can bring that to the test if you want to. But you should be able to do cross products, and you should be able to see how A cross B is equal to 10i plus 6j plus 2k. All right. So if you need to do some other review of cross products, go try to get that information. It's really pretty easy if you remember the right hand rule. If you remember I cross I, j cross j, k cross k is 0. It's not too bad. Okay. Now in order to calculate the moment of about a point A is equal to r cross f, where r is a vector from A to any point on the line of action of the force. And I underline any, okay, any point on the line of action of the force. And F is a force that creates the moment about A, all right? There's another way to remember IJK, which way is positive if you do this circle. Some of you may have seen that. So for instance, I cross J is positive K. If you work your way around it counterclockwise, you'll see that it's positive. But if you go clockwise, I'm sorry, this is, if you go clockwise, K cross J, then you'll see that that has to be negative I. Okay, another way of doing it. All right. So method 3, using the R cross F method. All right. So let's say I have a force, okay, in fact, this is the same force we've been using, right? It's the same force here, right? Force equals 30 pounds at a 60-degree angle, same force from the previous video, right? And you broke it up into components here. You had 15 pounds to the left and just about 26 pounds up, right? Well, you can take that same force and you can put it into this vector right here. F is equal to minus 15I plus 25.98J, because that means 15 pounds to the left and almost 26 pounds upwards in the positive J direction, right? So that's your force F, okay? Now, for force R, you can pick any point that goes from A to it has to go from A, any vector from A to any point on this red line, the line of action. And notice I've drawn quite a few examples here in green. But why would you want to make it any more complicated? You should always pick the simplest one. The simplest way to go from A to the red line is to go straight across, okay? So and that's 5 feet. So the simplest R vector you could choose is simply 5I, okay? You don't have to choose 5I. You could have chosen any one of these vectors, but why make it more complicated than it needs to be? Just choose straight across. R equals 5I. So to calculate the moment, you say R cross F. So it's 5I cross minus 15I plus 25.98J. If you calculate the cross product, you get the moment of 129.9 K foot-pounds, and that's the answer. It'll match method 1, it'll match method 2, and like I said, this is a great method for 3D. Okay, and so in the next video, I'll show you how to use this in 3D, which is really the preferred method of doing 3D moments. Okay, so hopefully this is helpful to you, and I've now shown you how to do method 3 using the R cross F method. Watch video 8, which we will get into more examples in 3D.